Hello and welcome to this new tutorial today about Leap Homebrew Engine, an all-new game and software engine for homebrewers. It has 2D and 3D support, it supports visual programming, the first of its kind, and it's compatible with several editors, like Blender, Tide, and many more. You can download the editor for Windows and Linux, and you can also join the community on Discord or access the documentation. So the engine itself supports multiple platforms such as the Windows, Linux, the Switch, the Wii, the Gamecube, and Sony's PSP. So let's take a quick look to the documentation, which can be accessed from there. So the documentation is very important to find some tutorials and also to find a glossary of all the functions that are available. You can also create your own plugins and everything else, and yeah, these important sections before to start Leap Engine to have some insider tips about stuff that can be good to do and that can be not good to do. So I have downloaded Leap Engine. Let's start it right away and see. And now for this walkthrough, we're gonna start by the 2D platformer project, which you can open directly here by clicking there. You also have the other main links for any resources you may need. This is the scene manager, so you can split your project into several scenes for any appropriate situation in your project. For example, here the main is the main menu, and we also have the first level and the test scene. So we're going to use the two today, and we're going to start by the main level. You can use manage scenes as well to add scenes or delete scenes as required. So here we go, we open the scene. So first I'm going to start with the layout walkthrough. So this is the code editor. It's here that you essentially type your code and your scripts and everything. So to be able to type the code, there is a syntax. So it's a Python syntax, and there's also something else. You can check the API, how it works, by going through here. So here you have all the main available methods and everything else as well, also the additional methods to be used by your project. So for example, how to create assets to be used. So for example, like for every object in your scene, it needs an asset. So let's say you have a texture of your character, and then you want to materialize this character in your scene. So you're gonna create an object, and this object is gonna embed this asset. So it's gonna show the asset that you have beforehand imported into the project. So for example, like for this, you just create asset texture, you use this API, the name of the texture you want to give him, and the file name of actually the image file, the JPEG, PNG, everything like this, and then you create a sprite for it, because since it's not a 3D object, it's in 2D, so then it has to be managed as a sprite. So then you just create sprite, the name of the sprite to be able to be used later as you want to move the sprite or anything else. The asset, so here you have to use the asset you previously created this name. And you also have the other coordinates, the layer, on which layer you want to draw the sprite, in case you want, for example, you have a background and you want to draw the sprite on it. There's also several script examples which may be very useful for your journey to go through and to see, to give you inspiration on how you can do things. So let's get back to our project and the layout. So this was about the code editor in Python, which you can also zoom by going into this area and then zoom with your mouse. You have the visual script. So for now, the visual script is gonna be disabled. Why it's gonna be disabled? Because you can do the two in one project, the two actually in one scene. You can do the two in one project. So for example, like let's say you're gonna create your scene by using visual programming blocks, then when you're gonna save, it's gonna override all the code you've written. So that's why like it's not compatible. And the opposite is also true. If you save the code that you write manually, it's gonna override the blocks in the Visual Script Editor. So yeah, make sure to only use one of the two modes. I'm gonna show you later how block programming looks like and how powerful it is. So now you have here the File Explorer, so it shows all the files that you have in your project and that are usable by your project as well. And you can also see that we have two folders, and these folders actually are linked to the other scenes, because then you can have independent assets to be used between the scenes. So let's take a look to it. You're gonna find it in the project folder, and then you go to a 2D platformer, and then you can see that we have them. We have the first level. So we go to the first level, and then we find again the script. So you don't have to touch this. This is managed by the IDE. But then inside the assets, you do find all the sprites that are gonna be used by the first level. So that's about the scenes. The engine logs are not to be used. The console logs can be useful, however. So that's everything that's happening in the engine or when you execute the project. So it's nice to always take a look at it when things go wrong to have more hints about what could be the issue. This is the application window, So you can preview and also enable the auto preview. So for the auto preview, every time you're gonna save your code or save your blocks, it's gonna automatically refresh the screen and refresh what your game looks like. So for example, let's see, now we're gonna preview. It's gonna be full gray because actually we have a transition that's I'm gonna show just after that opens up to open up the menu progressively. We have preview and we have play scene as well. So for example, we're gonna play this scene and let's see what it looks like. So that's our main menu, for example, and now we're gonna play a bit. And here we go. So now we are in the second scene. Which I'm going to show just after to see a bit deeper in the code how it has been developed and how easy it is actually with Leap Engine. So this is also a camera setup. So that's, for example, when you have a 3D scene, you can enable camera global, and then it's gonna be the standard camera for the scene, and you can directly refresh it by changing the coordinates and see what it looks like in 3D. However, if you already use a camera in your code, the one in your code is gonna override the standard camera. Something else now, that's the shaded wireframe and lighting. So that's in 3D, for example, project. I'm gonna show that after, just later. And now here we have the hierarchy. So for example, yeah, when you execute your project, when you execute your scene, actually, you can get a list of all the assets that are loaded by your project. And also when you play the scene, you can have a preview of all the scenes, of all of the objects loaded in the scene currently. So that's also interesting and could be important for troubleshooting or for just having a deeper look on what's happening. So let's open again the scene manager and see what the first level looks like. So we're gonna now preview the first level, where it's not gonna change a lot actually, because as we have the same transition than before. Let's play the synth out. And now we can see, for example, that we skipped the main menu because we are directly in the first level scene. So we can see that we can collect cherries and go around, and we have a tile set. And this tile set actually has been created in Tiled. So I'm going to show you quick what Tiled is. That's a level editor you can use on Windows or Linux. I'm not sure there's other platforms as well. That allows you to create actually your layout, your level, and then this is directly supported on Leap Engine. You can directly export it and have it here. So for example, I'm going to open Tiled here on my side, and you can see that we have the same level. Just this yellow blocks in the game, I have instructed in the script to replace them with the cherries that we can collect. So we can also have after the animation. So you can directly design your wall level here and using all the toolbox that Tiled allows, and import them in your engine by exporting a CSV file, export as CSV, and then use the CSV content in your code. So let's see what it looks like, for example. So here this class is actually about the transition, is to manage like the opening and the closure of the scene. That's why like we have a gray image right now. Set target FPS to 60 FPS, set camera to 00. Enable texture pixel also because we want the pixel effect since it's a low-res sprite, so that we can use that. Same thing, you can have more details about all the setups in the API layout, in the API glossary. So this is the start function. So this is called once when the scene starts, and it's usually here that you're gonna create all your assets to be used after in real time in the update function that is just after. So to see what do we do here, we first create a lot of sprite sheets because the wall level is based on sprite sheets, and then we have the create tile set. So the create tile set is exactly what we exported from Tiled. So it's about like where are the sprites in your level, and you don't do that by hand, of course. You just like export it directly from Tiled and then go through the CSV file, copy paste the CSV file and put it here. About all the rest, so this for example is what's managed, because then like you can interact with the tiles that you imported, and then this is gonna for example replace the sprite we saw, the block sprites, to the coins. We also create all the sprite sheets for the player. For example, the player animation, they are all sprite sheets. We can take a look to it, for example. So we can see, for example, this is the idle animation, or we can also have other ones, for example, when our character goes left. And then we have the update function, which is executed every frame, and that's basically the heart, the engine of your scene. So that's where all the magic happens, where everything moves, because if you only do start, then everything's gonna be static because it's only executed at once the scene is loaded. So here we have a lot of logic behind like how the player interacts, gravity, jump loop, move left and right, camera, and yeah, interaction with the cherries, for example, and the UI as well. For example, set sprite from text UI score, and we refresh the score when there is a collision with tileset obj 155, which is the block here, and that is translated to the sherry. Sorry. So that's all about the 2D project. I encourage you to go through it and take your time to understand how it works and everything. We don't have a lot of time here, but yeah, feel free to take your time, use the glossary as well for other methods to know what the methods do, and then it's gonna be clearer and clearer as you go through. Now we're gonna open a 3D project. So make sure also to store all your projects in the projects folder. So this is where you can find all the projects you're developing. So for example, we have project, that's the 2D platform we used. And now we're gonna use another one. So that's our 3D project. Let's have a preview and see what it looks like. So that's our 3D scene. I'm going to execute it. Okay, nice. So we can see we can move the ghost, but the ghost can't leave. We can also move it up and down. So for example, this is just an example of how you can have a 3D project. So the 3D model is an OBJ file, a wavefront OBJ, and that's actually already created in Blender. So that's exactly the same scene that has been exported from there. And something there that is really nice is that you can create directly colliders from there. So for example, let's see what the colliders looks like. So that's our 3D cubes that you can scale to make sure that your main character doesn't leave them. So for example, these are the colliders in a group that's named, in a collection that's named colliders. And that's the actual scene. So a Python script is provided actually for Blender to actually export all the colliders you may have automatically. So you just have to export the scene after as an OBJ file and then use the colliders code script. The script is going to be pasted to your clipboard and to be used directly there. So for example here, all of this line has been developed, has been created by the script that I just shown, and I just copied pasted the same thing. So you can find the script in the editor folder and then in plugins folder. So it's gonna be the blender underscore box collider.py. That's about the 3D project. Now let's see how the visual programming looks like. So we're gonna open this project, open the main, have a preview, and so that's the scripting. So sometimes it bugs, it says that you shouldn't override, but if you know that you have been using this project with the blocks and it's not warranted, then you can just discard the warning. So for example, here we just created the whole project using blocks. So we have the start group, so it's the same logic, and then you have the update group. So for example, yeah, you can create the asset texture directly here, the sprites as well, and then in the update you can just create the whole rest of the logic, and it's pretty much the same. As you can see, like we have had the if it's button right group, and it's exactly the same. Because actually why? When you save this, it goes translated to the script. So that's why like it follows the same logic. So to create that, you have several groups from here. So in the engine groups, you have everything that is related to the engine or the object management, the asset management. Logic is everything about logic, so the conditions, if, testing, if it's not this, loops, math, text, yeah, if you have text, for example, for the scoring, when you want to display the score. In MISC, you have other stuff that may be useful. So, for example, yeah, you have to use these blocks to convert a number to a text. Or you can also embed directly Python code in your block in case what you want to do is not possible with a block, but you still want to keep using the block system. It's definitely possible to do that. This is a global variable, so make sure to use that if you want to access your variable everywhere in the scene, because otherwise it's not going to be able to be used. And this is plugins, so you can develop also your own plugins for the engine. So let's say you have developed some code, some special code, and you want to use directly one block to do that. You can definitely do that with the plugin system. You can find more information about it here. Advanced, create your own plugin. And then yeah, you just follow the instructions here. And this actually you can also like just to see how this plugin is developed, because it's provided as a sample for more complicated plugins. So that's pretty much all about Leap Engine. So now I'm going to show about the compilation process, how to deploy your project for platforms. So we're going to come back to the first 2D platformer project. We're gonna play the scene. So for example, yeah, for this example, we're gonna disable the shading and just like do everything in wireframe. So press Ctrl S every time you want to save. Now we put wireframe and we play the scene. That's what it looks like. It only looks squares. And also, yeah, we have the test here. So that's why it looks squares, because it's all about like the sprites, and sprites are squares. So, but for example, yeah, if we do the same on the other project, it's in the 3D project, it's gonna look a bit better. Yeah, for example, here you can see how it looks like with wireframes, and you can see also the complexity of your 3D model that can be used, for example, if you're targeting limited consoles, for example, such as the PSP that have limited capabilities, to make sure that your 3D models are not too complicated, or your sprites are not, there's not too much sprites on the screen at the same time. I mean, it's still better for sprites, like it shouldn't be a problem, but for 3D models, optimization is very important. Something else too about the update block. So you may think, for example, that it could be frame rate dependent. Like let's say the game is running at 30 FPS, and then on another platform it runs at 30 FPS. It may not run at the same speed. Actually, Leap Engine, like we have developed a special system for this, so it's gonna adjust the rates of the updates in the code. So it's not gonna update at the same time the frame and the code to make sure that the update is consistent. So that's why you need to put set target FPS and put the target. So for example, if you developed your logic in a way that it should be executed 60 times per second, then you put this, and then the engine is gonna adapt and not overcompensate, just compensate how much updates are required per frame to make sure that the experience is consistent between platforms. So let's get back to the 2D platformer again and just build the project. So to build the project, to deploy it, you just go through build application button here, and you have the build assistant. So you just select which console or system you wanna target. So for our example, I'm just gonna put Windows, because actually this needs an emulator if you wanna run it on directly on your own laptop. But it's not, I don't recommend to run on emulators because you don't get the real experience, and sometimes the emulators are not very accurate in the representation, especially it's homebrew. So sometimes not everything is really supported on homebrews when on emulators and when it's on real consoles. So I'm just gonna build for Windows for now. So then, yeah, when it's finished, it said it's done in release folder. So we're just gonna go to the release folder. So you go through, I am in the IDE folder, you go to the release and you go to Windows. And then you execute Gen 7 Windows. We can see that we forgot to actually remove the wireframe setup. Let's do that so we make sure that it looks like what you want to look like. I save again. I play scene just to verify. Perfect. And now I'm going to close this. I'm going to build up the project. Windows. Wait a bit. And it's done in release folders. Okay, we go back there. And then we execute again. Perfect. And then we can start. Playing our level. So that's our level, as we have developed previously. So let's say now you want to create the project for another platform. So let's say I'm gonna deploy it for the Nintendo Switch. So just click on Switch, and then you go there. So now let's get back to our IDE. I hope the walkthrough was interesting, and I explained everything well enough. And yeah, as a final note, please make sure to verify the documentation, to walk through, to read. Actually, the documentation is not very large, but it's very important for everything. Like here, for example, you have an example of the layout. This, for example, is a Gamecube project, which is included too in the projects folder. And you have everything else. So yeah, have fun, have a good day ahead, and have fun with the Leap Engine. I can't wait to see other projects that can be created with. Thank you.